Thank you all for joining us this morning. My name is Danielle Kutka. I am Project Manager at eMobility Europe. This is our first webinar for the ZEV-UP project. We have a nice lineup of speakers for you today. We will be discussing the topic of battery swapping, the technology, the solutions that it offers in today's e-mobility landscape, and focusing on ultra-compact BEVs, highlighting the work of some innovation projects that are working on this topic, as well as some of the key aspects concerning market uptake and consumer aspects. So you could, Katerina, if you could go to the second slide. This is an overview of the agenda for the webinar. And before I welcome our first speaker, I would just like to remind you that this webinar will be recorded and available afterwards. And should there be any questions from the audience, we encourage participation. Please use the Q&A function at the bottom of the Zoom screen that you will find. Depending on the time allotment, we will either answer questions immediately following the presentation. If we run behind, then we will save everything until the Q&A session at the end. So with that, I am delighted to introduce our first speaker, Emin Aliyev, who is the project coordinator of the ZEV-UP project. He is the manager of Green Urban Mobility at Urtico ITS Europe and has a background studying public policy, business management, European economic integration, as well as innovation management. So Emin, thank you for joining us. And with that, I welcome you to share your screen and your presentation.
Hello, everyone. Do you see my screen? Is it okay?
Yes, it's good.
Okay, great. Hello, everyone. Yeah, I'm Emin Aliyev, project manager at Urtico ITS Europe and involved in clean and urban mobility focus area. I'm also the project coordinator of this ZEV-UP project. And I would say that the webinar is inspired by this project and is done under the framework of the ZEV-UP project. So today I would like to present you a few points in regard to the ZEV-UP project. And so I will try to cover the project goals, major innovations, and then give you overall the project overview with the consortium activities and outcomes. And if you are interested, then yeah, we will also tell you how to be involved in the project. And of course, if any question, we are open also to your comments, and yeah, we would like also to provide you any answers. In terms of challenges, when we started this project, we had in mind a few challenges that we wanted to tackle. And so, as you know, we know that there are high costs of urban battery electric vehicles, and also urban congestion, parking conditions. Parking spaces are becoming more problematic in our urban areas, and also the future evolution of our urban areas should be taken into account. And also on top of that, we have got also diverse user acceptance, and also delivering mass market capable of frugal versions for emerging markets and producing versions in the EU. And then also it's not proposing a car design, development, demonstration, and then putting it in the market, but also how to smartly integrate it into existing urban infrastructure. So with those challenges, and of course, this sustainability and environmental impact were also among the major elements that we wanted to tackle. So this EU-funded ZEV-UP project we started a few years ago, and this project was funded under EU Horizon Europe Research and Innovation Program. The project aims at developing an ultra-compact battery electric vehicle that is user-centric, so this part is really important, scalable, modular, and also zero emission. This project aims also on providing passenger and goods transportation. The project also incorporates a swappable battery system and integrated solar panel on the rooftop, enhancing convenience, adaptability, and reducing operational costs. And of course, when integrating such a system, we have also in mind how to propose the business models that would really work in overall system. So the battery as a service and also other related business models. So we are, I would say that at the moment exploring that, and then we will try to give you more overview a bit later on. And also we will look into the policy interventions because before we put the product in the market, we would like also to check, the legislative regulatory background, different scenarios and then strategies, how this, the ZEV-UP project can be strategized in short and then long term, and then how the battery electric vehicles uptake can be done in various markets. As we said, we are not only looking into a European market, but also the market at international level. And then now we would like also to give you a brief overview of the innovations and then high-level product description on the ZEV-UP project. So first of all, we aim developing affordable but also frugal, so cost-effective car. So in this project, we design, develop, and demonstrate this ultra-compact car with swappable battery system. So in terms of design, yeah, we aim to have a really user-centric design. We checked also the user expectations, how these user expectations can be met at European level, but also international level, with the help of our international partners. In this project, we will produce 3 versions of ZEV-UP car. So first car, as you can see here, will be purely passenger car, will be smaller version with 2-seater, but also there will be also storage for your luggage or travel bags. And second version is a bit longer version, and then this version will include 4 people. So it will be really the people will be quite comfortable. So this car is really different what we can see in the market as Citroën, Ami, or others. So even taller people can fit there. But this car, although it's an ultra compact car and then will fit for 4 people, will also have some space for luggage and then storing maybe small travel bags and so on. And the third version will be purely commercial car, with 2-seater, but with really good storage system for small businesses, for fleet owners, etc. This is, as we said, a modular vehicle platform, so adaptable vehicle platform, a scalable chassis, and this project will use also lightweight and sustainable materials. And I'm quite sure that our next speakers will be able to tell us about more. So because this is being done already, and then reduce material usage as well. Solar panel, so there will be a rooftop solar panel integrated to the car, and also the swappable battery system will be done through modular battery pack. This swappable battery system will work with the help of support of the service stations, dedicated service stations. And the innovative individual wheel drive also will be integrated among those innovations, and the local production of spare parts also will be done. And of course, this car is 0 emission and also is a quiet vehicle. So these are the major innovations and the high-level product description of ZEV-UP project and ZEV-UP car. In terms of technical specifications, these are the specifications that we aim to integrate to the car. Well, this is not really the exhaustive list, but maybe the element that would be interesting for for our audience that this smaller version that we highlighted will include those options. And then at the end will cost around 8.5 thousand euros, and the other one 10.5, and the commercial one will be around 10,000 euros. But again, yeah, our experts will also tell you a bit more. We are at the start of the project, so we have done already 15 months of project, and it's a 3.5 year project. The kickoff was done in January 2024, and then the project will be closed in June 2027. So the car will be then fully, I would say, homologated. 18 partners. It's an international consortium. As we said, we do not have only European partners, and then we have also very good geographical scope of the consortium, but it also includes the University of Cape Town from South Africa, and also Lahore University from Pakistan, and they did also an amazing job when exploring these user expectations, different models, KPIs. And the budget also is not really big, but also really considerable, and then the efforts are coming from the EU, as I said, Horizon Europe program, from UK funding authority as well, and also some budget are also provided by our industrial partners, because those costs are not fully covered. 2 demonstrations will be done in this project, one in Budapest and another one in Istanbul, and we will start the demo preparations already end of this year and next year. In terms of activities and vertical activity, technical activities, so we are looking on the work package 1, user-centric strategies for global diffusion of frugal BEVs. So user expectations, different KPIs, usage models, and well, good news is that this work package 1 has already been achieved with the system requirements, although the documents are not all of them public, but we are happy to share the summary, and then please check our website. We will talk about it a bit later on. Under work package 2, we are also looking into vehicle design architecture components with digital twin. Work package 3, we have a vehicle prototype building, and this is done by our Ford colleagues. Work package 2 by FEV Turkey, and then work package 1 by Roy from our partners from Greece. And work package 4, as I said, we will be in vehicle demo phase, and this big activity is led by our colleagues from CERT, Greek Research Center. Work package 5, there we will look into evaluation impacts and market uptakes done by the University of Leeds. And Ertico is the coordinator of project and leading coordination, project management, communication, dissemination. But we have also other partners that you don't see here, like e-mobility Europe, also organizing this webinar, and also leading stakeholder engagement, and ICOR leading technical dissemination. So 18 partners are really together as a great team to implement the project. In terms of outcomes, at the end of the project, well, this user needs definition, market insights, and KPIs guiding this frugal BEV development and evaluation will be fully done. I would say that most of the work has been done, or the baseline work. And then effective design and development of frugal and affordable urban passenger and commercial BEVs, as we said. So 3 different versions will be there. It's scalable and modular vehicle architecture, so adaptable platform for different users. Swappable battery system will be integrated. Digital twin with smart integration. So this is a virtual replica of a ZEV-UP car that will simulate the design, behavior, and vehicle functionality and performance in real time. Sustainability and circularity, we will focus on using recyclable materials, a lightweight structure, and also environmental impact. And also we will look into regulatory and business model innovation. So these recommendations will be there at the end of the project. And I would say that, yeah, we already started thinking about them. More project progress, more we have, of course, ideas and inputs that we know that we can be really helpful throughout this project. And we have also a really good advisory board. And then, you know, if you are very much interested, this advisory group is also open. Please join. Otherwise, you can collect all relevant information through ZEV-UP EU project. Follow us on LinkedIn. We are also sharing updated information about the project. And of course, if you know you have any other comments, questions, please contact us. Tell us a little bit more. And I'm quite sure that, you know, if you stay with us, our next speakers will give you more details, more technical views, and also maybe, you know, a few pictures. Thank you very much.
Thank you, Iman. I am checking the chat. There are no questions for the moment. I think to keep with good time, we can continue to the second speaker and have some questions at the end during the discussion. So with that,
Yeah.
I will welcome our second speaker, or second speakers, excuse me. We have two presentations coming up on the safety market readiness of battery swapping. And also a look at the ZEV-UP frugal modular EV prototype. This is a presentation from Alakan Yilmaz from BMOBS and Emre Kinav from Ford Otosan.
Hello, thank you very much. This is Emrah from Ford Otosan. I will start and then Alican will take over. My screen, can you see it right now?
Yes,
Okay.
we can. Thank you.
So very shortly, we are actually trying to bring in more battery electric vehicles into cities. That is the targets for the Commission's Fit for 55, and as also more, which we know we can achieve. But today's reality is when there is less incentives for the electric vehicles, the uptake in the market goes slower. So what we need is an innovation to disconnect this tie, the electric vehicles with the incentives. So without incentives, this should also continue to grow. So here we need a frugal vehicle, a cost-effective, feasible vehicle for all users in goods and passenger mobility in the cities. So it should be a very high user acceptance of the vehicle, of the solution, the whole business plan, so that the vehicles become more seamlessly integrated into our lives. Electrification today is taking place in basically all the segments that you can see here, starting from mini, micro to all the way to heavy duty trucks. But what we see in Europe with the top selling vehicles are all C or above C segment vehicles. So basically large vehicles. And the numbers you can see here, these are the actual numbers in Europe. So it is good for the emissions point of view, the vehicle emissions, but this is not solving our issues regarding the other problems that we have in the cities. Basically, the roads and the parking areas, which are scarce, and the 95% of the time, actually, the vehicle is parked. The remaining 5% of the time when the vehicles are moving around, actually they create the current traffic congestion in metropolitan areas, which are actually suffocating our cities. The electric infrastructure, not only for charging the electric vehicles, but the whole city's electric infrastructure actually, because if we have all these vehicles electrified, if we have such a plan, basically the electric infrastructure of the cities are not enough. and we need much more infrastructure cost that is much more than the vehicles themselves. So that is a big problem for now. Here in ZEV-UP project, we are looking into the issue as how we can most efficiently address the drivers or the usages in the city, both for goods and people mobility. When we look at the daily mobility needs, 30-35% of the drivers drive 0 to 10 kilometers, and 30-40% of the drivers drive 10 to 30 kilometers. This is the daily range. So basically, up to 30 kilometers is around really 60-70% of the people, of the drivers that use their vehicles. After this point, the percentages start going down. So 15 to 20% of the drivers drive 30 to 60 kilometers, and 5 to 10% drive 60 to 100 kilometers. Above 100, it is only few percentages, so which are not in where we are addressing with ZEV-UP projects. But all the rest, so almost 98%, you can see, are in our range of giving or proposing small electrified battery electric city vehicles. We bring in a safe, modular, and flexible vehicles that are actually feasible and frugal for the end users, for the citizens like us, to buy these vehicles. But in ZEV-UP project, we are also working on new business models where we can actually rent or bring as a mobility as a service using these vehicles. So increase the usage of sustainable vehicles in the cities without even making people to buy these vehicles. We are basically developing the vehicles on our partner BMOP's current design vehicles. So this is an L7 type vehicle, which is 100% battery electric, with range up to 150 kilometers and speed up to 50 kilometers per hour. It has a best-in-class interior speed and less than 4-hour charging. What is important for us also is bringing the driving age down to 16-year-old from what we have currently as of over 18. And in the ZEV-UP project, we bring in some innovations. Actually, what we also don't have before, improved 50 kph crash safety for the people using the vehicles, active safety functions, the in-wheel motors for better dynamics, vehicle dynamics, ZEV-UP remote control and 5G remote drive of this vehicle. So basically the teleoperated version of this to enable different kinds of mobility as a service usages in the future. 2-seater, 4-seater version and cargo carrying versions, which is given to us with the modularity of the design, and the 3D printed customized parts for people who can design their own parts. What is important for us in this presentation as well is that we have 3 different battery options for different ranges and different usages. And for changing these batteries, both inside one vehicle as well as among different vehicles, we will have a swapping, quick charge and swapping option. So here, why we use battery swapping? First of all, fast charging is, or battery replacement, it can be seen as a fast charging for all the delivery vehicles, all the on-demand taxi, car sharing, etc. So vehicles which are not owned by the end users. We enable business as a service business models. So buying the vehicle with minimum size battery pack and then renting bigger packs whenever you need it for your vehicle that you own. Buying a vehicle without battery pack and leasing the battery pack, pay gradually as you earn or save money. Buying vehicle without battery pack and paying monthly fees for energy and battery. So these are some of the options we can bring in, and we are actually studying right now. And now we will go to the battery swapping and the techniques we come up with after studying different options. And what we see is easy charging at home or coffee-like environment where you have to take out the battery. For such vehicles, this is basically a vehicle that is around 1 ton, so 1,000 kilometers when it is full, when it is packed. So taking out the battery and then bringing back in charge is not seen as an option for us because it is either like 2 plus 40 kilograms or 3 plus 25 kilograms of battery packs, which you need to carry. These are not so easy for a human to carry and safely carry as well. So at this point, I would like to give the floor to Alican for the concept alternatives which we have studied in ZEV-UP and perhaps which we have chosen.
Okay, thanks, Emrah. And when we look at the concept alternatives, we had 3 different options. Option 1, which is quite usual and popular in e-bike and e-scooter applications, a single piece of 1 or 1.2, 1.5 or maybe 2 kilowatt-hour battery pack weighs around 10 to 20 kilogram in case of 2 kilowatt-hour battery pack. You can charge at home, cafe, or take a recharged one from the depot. It's very good option for the motorcycles because they are mostly equipped with 2 kilowatt-hour battery packs. And we said, okay, this is applicable only for small battery packs, not for the vehicles. For option 2, it's a silence and zero EV approach, single or double piece of 5.5 kilowatt-hour battery packs weighs 40 kilogram. In that case, you cannot lift 40 kilogram by yourself, so you need some kind of a trolley system. The trolley system is integrated to the battery pack itself, but still it's 40 kilogram. You can also charge at home or cafe or take a recharge at 1 or 2 from the depot. It's good in theory, but in practical, it's not, we don't think it's a practical and safe solution. Why? Because it's very heavy again. Especially if you have even you have a trolley system, it's not easy to lift for the curbs or other entrances as well. And it's not safe because you are taking a 40 kilogram battery pack with you to your location. It looks like a little bit challenging for us. And another thing, which is much more important for us, battery aging balance in terms of the lifetime performance problems in future. So it's a 2-piece battery pack. In that case, in order to keep the aging, the balanced aging between 2 battery packs, you should couple 2 of them. And in that case, it's not easy to manage to take one from the depot, another one, or a random one from depot, or balance 2 of them in your car. It's a technical problem from our perspective, so we decided to say, okay, it's not so practical and not good for better aging performance. And final option is the strategy concept used in Neo, Tesla, CATL, and XEV vehicles as well. A single or multiple piece of battery packs replaced in battery swap stations, manually or automated. You can see highly automated version of Neo, but you can also provide such a service manually, maybe more time. But for the battery as a service business models, you are not in rush, so maybe you can provide such a solution. That's what we thought at the initial stage. And this is applicable for all vehicle types, no high voltage risk for users, especially for customers, and enable battery as a service business model as described by Emrah. We can jump to 12, Emrah. Okay, our biggest concern is for the carrying a battery pack and moving the battery pack is the problems related with the the connector and oxidation and other error modes, because even it is removed from your vehicle and going to your home, it's still a part of the vehicle. If you have any kind of a problem, in that case, the vehicle manufacturer will be the primary responsible. So this is why we don't want to do it in your house, office, or cafe. Okay, we can continue. We have two different concepts from the technical perspective. We said, okay, we are looking for a battery pack which can be replaced in a battery swapping station manually or automated, but what kind of a technical concept? We have two different concepts. For the first concept, there's a master BMS and PDU in the vehicle itself. We have multiple and identical battery pack, small battery pack solutions. So you can combine 1, 2, or 3 of them, and which has its own BMS and the connector inside. They're identical. So you can take one of them from the depot or from somewhere else, or it's available in your swapping station. You can combine 1 or 2 or 3 of them. There's still a complex aging balance and electrical interface and charge algorithm problems from the technical perspective, because at the end of the day, there are different battery packs. That means different aging profiles. So, for example, you can combine random 2 of them. In that case, you should balance them somehow. And the electrical interface is much more complex. For the 3 battery pack version, you should have 3 connectors to couple them. And for the charge algorithms, you should take the aging balance into consideration. It makes everything much more complex and challenging. It's not possible to make a structural part for underbody, because we would like to use this battery pack as a structural system to reduce the weight of the vehicle. For L category vehicle, you have a very limited weight reserve. So if you can remove some parts from the vehicle, because the weight of battery pack is not included in the overall vehicle weight, if we can remove some weight from the vehicle, by that way we can save some weight. So we said, okay, we should use the battery pack as a part of the rolling chassis as a structural element. In that case, it's not easy to use multiple small battery packs as a structural element. But the good thing is, for the small battery pack version, it has a lower battery pack mass. If we jump to concept 2, in that case, we will have only one PDU, identical BMS and the connectors, but integrated into the identical casing. In that concept, the casing, BMS, connectors, PDU is identical, but the battery pack, the cells and modules are different for different options. For example, you can rent battery pack 1, which is 6.6. For the battery pack 2, it's around 12 kilowatt hour, but same casing, same BMS, same connector, same PDU. And we have another battery pack, which is the biggest one, with the identical the structural casing. This is important for all these 3 options. You should keep the casing as it is, similar, because it's a structural element of the vehicle. So in that case, we will have 3 different modules, but identical casing for us as a solution. In that case, we will have easy easy aging balance, electrical interface, especially while replacing, and charger algorithm. Possible to make a structural part for underbody. In that case, especially for the smallest battery pack, we will have a higher battery pack mass, but as I mentioned, it's excluded from the overall vehicle weight, so it will not be a problem for us anymore. If we jump to the next slides, in that case, we have already compared the concept 1 and concept 2, and we decided to continue with concept 2 regarding all these attributes. If we jump to the next slides, here's how it looks. The purple parts and the pink parts, is the casing is identical for all three battery pack options. And the electrical interface you can see on the right side is same for all the battery pack variants. We just and also the power electronics and the BMS is also identical for all three options. We only replace the modules and cells inside to provide three different battery pack options. In that case, if you go to the battery swap stations, you will buy or rent an identical battery pack from the outside, but the inner side is different according to your how can I say budget. So if you go to the next slides and the final slide, how we manage and how we replace this battery pack, we have two different options: automatic or manual swapping option. For the automatic one, there's this very small platform over the floor. So you jump over this platform, and then AMR is going under the vehicle, and then installing a battery pack or removing the battery pack. This is how we automate the system for the manual swapping stations, because at the end of the day, even it's a cost-effective variant on the left side. If you want to reduce the cost of the electrical infrastructure and also battery swapping infrastructure, in that case, you can lift the battery pack with a small lifting element. And if you have some kind of a tunnel or channel somehow, like the traditional the service centers, you can lift the battery pack into place and screw by technician. By that way, you can remove and replace the battery pack. So this is what we are planning for our battery as a service model. We have two different usage patterns. For the private users, if you want to rent or buy a battery pack, and the replacement frequencies is around maybe 6 months, in that case, you can go to the second one. But if you have some kind of a car sharing or robotaxi platform, in that case, you can take the left one and replace the battery pack in minutes by automatically. This is how we approach this technical challenge. Okay, thank you for your listening to us. If you have any question or answer, we can answer it.
Thank you so much. We did receive two questions that came through the Q&A. The first one, it's a bit out of scope. I will still ask it for the sake of the Q&A. How does the transit heavy vehicle scenario look like for electric vehicles? And I'm wondering if this is also, well, in the context of the battery swapping.
Currently, we, as Ford Otosan, we are manufacturing the Ford Transit, electric transit, and the Transit Custom as well. We are already selling these on the market, and it will continue as it is. It's already a good vehicle that we developed, but I cannot tell more about the future products on the Transit family.
Thank you. The second question that came through was whether these cars receive government subsidies.
In case of L6 category, you have some government subsidies. In ZEV-UP project, we will have two different vehicle variants, L6 and L7. For L6, yes, you have some government incentives. For L7, not yet, but in future, probably yes, especially for the, how can I say, for the goods transportation applications to replace the big trucks in the cities, because L7 vehicles provide much more loading capacity versus L6 vehicles. So yes, for some of them for today, for the remaining parts, probably in future.
Was there another comment, Eamon, that you wanted to raise, another point?
As we said, so these three variants that we presented, they are done on the EU-funded ZEV-UP project. And of course, there is also background, as Alican explained. But these three variants we are designing, developing and demonstrating on the ZEV-UP project, and it's funded by EU and also UK government subsidies. But apart that, the industrial partner also covering some part of the costs, so like up to 30 or 20% of their costs. But of course, I believe that the costs are even bigger. But we are doing all the efforts to stick this to the budget that we receive from the funding authorities that I mentioned. But otherwise, in this project, there is no other national subsidies. Thank you.
All right, great. Thank you so much. So we can proceed then with our third presentation. We have Alihan Üstel, who is an electronics design engineer at Aspelsan, a battery manufacturer in Turkey.
Yes.
Please, thank you for joining us. Please, whenever you're ready.
Welcome everyone, and thank you for joining today's webinar. I want to do thanks to Mr. Dejan and Emrah detailed battery swapping system explanation. Yes, main topic is battery swapping and integration. I can explain and summarize all of this topic. Firstly, urban mobility challenges. Actually, city travel problems. I can explain that. Urbanization is rapidly increasing. Over 5% global population lives in cities, and cities are growing fast, and more people live in there. So that, but old ways of travel cause traffic jams, pollution, and not enough parking. We need new ideas for city travel. Their parking is limited and inefficient in high density areas. Secondly, rise of compact electric vehicles. Another saying as small electric cars benefits. To compact and battery electric vehicle, lightweight. We designed for 1-2 passengers in there. Very small electric cars solve many city problems. They use less energy and take less space. They are good for short trips in the city where big cars are not needed. Examples Tren MA microline vehicles developed by the ZEV-UP projects, and this L7 class electric vehicle. Another topic is the battery capacity. In that, actually battery size problem. Electric vehicle range is closely tied to battery size. Bigger battery longer range. Our ultra-compact vehicles have limited space and weight tolerance. Yes, people want electric cars to go far on one charge, but small cars can't carry a biggest battery. In this way, there is a conflict between range expectation and compact design. Another topic is battery swapping. What is battery swapping? Battery swapping means changing a car's battery new one. New one is fully charged in swapping station, maybe house. Generally, if battery capacity is lower than 5 kilowatt hour, people can carry this battery pack. But this project battery pack capacity is bigger than 5 kilowatt hour, so that battery pack liable to replace battery swapping. In their process can be automated, robotic, or maybe manual. enables quick turnaround under 5 minutes. Actually, this concept popular in Asian market. In China, Mr. Rajan explained detailed, and Gogoro in Taiwan use that concept. Another topic is benefits of battery swapping. All of these advantages: time saving, grid operation, scalability, cost efficiency, environmental impact. And depending on the leasing model in there, actually reduced front electric vehicle battery leasing. Yes, it's directly to and depending on the leasing model, the user will know who rents the battery with a suitable capacity. And in our project, and there are three different capacity battery pack. First one is smallest 6 kilowatt hour, middle of the capacity 12 kilowatt hour, and big one is 20 kilowatt hour. Yes, in that battery swapping helps both drivers and the whole system. Great for cars that are used a lot and can help they use batteries in smart way. Yes, battery swapping for small cars in this topic actually. Swapping batteries is very helpful for small cars. It lets them drive further without making the car heavy, which saves energy in that. Lightens vehicle frame and reduce design complexity. Another size sectoral application in battery swapping. There, where battery swapping can be used. Battery swapping works well for many types of vehicles. For instance, delivery ones, taxis can work better, cost less, and be used more. They swap battery quickly. Ride-hailing services, delivery and logistic, public transportation, for 2 and 3 wheelers, widespread in Asia. This way, reduce cost and encourage electrification for widespreading. Shared mobility, car sharing or bike sharing system can integrate swapping for higher setup time. This is our project overview. Actually, this project collaborative European Union and United Kingdom Research Innovation. In this project, main focus on developing a modular, affordable, swappable battery for urban mobility. Our priority, frugal design, affordability, and open innovation. In these real-world use cases, especially in dense European cities and in other countries. Yes. In this project, key features lightweight modular chassis and battery. Modular battery means that Mr. Alcan detailed explanation. One area in the vehicle, our car uses a battery that fits between the 4 valves. It connects to the car with 6 points. That and this is a main prototype design battery pack. All of these 6 points connected to battery chassis. Front of the side, this is a connector. This connector without touching, and it carries power and signals directly. Yes, all of this concept future markets. Actually, future changes with battery swapping. Battery swapping can create a new business idea and model. There, technology in the future. Things like subscription for smart logistics can change how we travel. In this battery as a service, integration with renewable energy system, potential artificial intelligence driven swap station advances in battery chemistry enabling faster and safer swaps. Yes, all of this topic is a new idea, but there is a rules and laws in government. Government and rules will be important to help battery swapping grow. Without clear rules, it might be hard for different systems to work together. Need for international standards on battery size, same voltages, same connectors interface. Safety protocols for public swapping station. There's a regulatory in there. Advantages for battery reuse and recycling. This project recycling second life usage battery pack connect to each other energy storage system using integration into smart city policy frameworks. All of municipalities is enabling infrastructure. Thank you for listening.
Thank you so much. We had a few extra questions come in, but because they're related to other presentations, we will get to them at the end for the discussion section. If any other questions come in regarding this presentation, we can also field those at the end. So with that, I will present our final speaker for today. We have Tommaso Landolfo, who is Regulatory Affairs Manager at Piaggio Group. That is part of the Horizon Project Stand for Swap. He is the chairman of the policy committee of the Swappable Batteries Motorcycle Consortium and has experience focused on Italian and European policies, also in the automotive sector. So without further ado, please, Tommaso.
Yes, thank you very much for the introduction. I will try to share my screen now. Just a second. Can you see the presentation now?
You can see it.
Yeah, okay, thank you very much. So thank you for this opportunity to present the Stand for Swap project. Trying to summarize the aim of the project. This is a slide. Wait, I cannot go on with the slides. Yeah, this one. This is to summarize what we want to avoid. So in other words, what we did with phones and laptops for many years in Europe. So push for a standardization roadmap to develop and boost innovation to market for swappable batteries and for the LCAT vehicles, so the L category vehicles, and try to develop a safe, secure, and of course environmental friendly technology that will suit L category vehicles. So this is the battery swapping for LCAT vehicles in 6 steps. This is one of the options that was presented before, I think, by Alican and Emra, because I was, of course, our main focus is related to two-wheelers, three-wheelers vehicles, but also small and light four-wheeler quadricycles, so L6 and L7 vehicles. We are talking about a battery that is around 2 kilowatt hours that weighs more or less 10 or 12 kilograms. So you can arrive to the swapping station as in the picture and easily leave your empty battery and pick up your new battery and swap it with more or less 60 seconds. So this is why we presented this Horizon Stand for Swap project and why the European Commission decided to finance this project. It's a project made of 8 partners. Both they are coming from manufacturers like Piaggio and KTM, also manufacturers of vehicles, but also manufacturers of infrastructure and recharging station like Swobby. And then we have the Senelec inside the project, the European standardization body, and also university and research institutes like Fraunhofer and ZEV-UP. And These are the four main objectives of the project. The first one is the identification of pre-normative research, so a mapping of all the standards and regulations that are already available and in place for this kind of batteries, swappable batteries for light mobility vehicles. And then the second one is the most important, is to trying to prioritize standardization activities. So define, in other words, which part of the batteries will be standardized. We will not focus our standardization on the whole battery, but only on the parts that can guarantee the interoperability and the compatibility of different batteries in different brand vehicles. So at this moment, we have identified the most important parts that are the perimeter of the bases, of course, the connector, and then also the state machine of the BMS, the battery management system, for the communication of the batteries with the vehicle and the swapping stations. Then we have the third objective, that is increase stakeholder engagement. So, of course, establish a dialogue with the standardization institutes, both at European and international level, industry, research, but also external stakeholders like municipalities, cities, where then this technology will be put in place. And then the fourth objective is educating and raising awareness. Of course, it's related to our activities of dissemination, where we will share the final result of our project. This Stanford Swap Horizon project works in really close collaboration with SBMC, the Swappable Batteries Motorcycle Consortium. This is a consortium that is that was born in 2021, created by many companies. Now it counts more or less 30-35 companies coming from both vehicles manufacturer side, but also battery manufacturers, infrastructure manufacturers, research institute, European and national associations of the industry. And while Stanford Swap main objective is to define which parts of the battery will be standardized and define the roadmap of the standardization, SBMC is focused on the technical side, on technical work, so on the definition of the technical common specification of the battery, so how the battery will be made. These are the advantages of swappable batteries. Many of the other speakers already speaks about that. In particular, I think in the first intervention, Emin mentioned already these advantages, but especially related to two-wheelers vehicles, we have many advantages for customers, reducing the range anxiety and easily exchange batteries in less than 1 minute. For the environment, of course, boosting the electrification of vehicles, the spread of electric vehicles in towns, helping in reducing congestions and improving the air quality. For manufacturers, because standardization has many benefits also from manufacturer side, with an efficient production and economies of scale, and also for cities, because swapping station, as we saw in the picture before, occupy less space than many charging points, for example, for cars that needs very large space for parking. And in 2 or 3 square meters, they can host more than 20 batteries in vertical. This is the state of play in terms of standardization at the moment. We are moving on 2 different parallels. Path 1 is the ISO 1, so the international standardization activity. where it was created the ISO TC 2238 Working Group 2 that is dealing with electric mopeds and motorcycles. And there, the international delegations that are part of ISO decided to split the job in the 6 different parts of standardization. And the SBMC, the Swappable Batteries Motorcycle Consortium, that is one of the liaison members of this technical committee, has taken the lead of 2 of these parts, in particular the part 2 related to battery mechanical requirements and the part 5 related to BMS. While at CENELEC, so at European level, the CENELEC, the European standardization body, received a mandate from the European Commission that is explicitly written in the Alternative Fuel Infrastructure Regulation, so the AFIR in the Annex 2, where the European Commission asks to the CENELEC to develop a technical specification for battery swapping for L category vehicles. So to fulfill this task, the CENELEC created the TC301 Working Group 19, Swappable Battery System for L category vehicles, where now STANFO-SWAP, SBMC, but all the national European delegations sitting in the CEN-TC technical committee are discussing about the technical specification of the future swappable battery standard. These pictures shows what was not approved at ISO level on the left of the screen. So the ISO delegations do not agree on standardize all the parts of the battery, creating a unique battery that can fit in different in one single swapping station and different motorcycles. But I decided to focus the job on, as I said before, on only the parts that will guarantee the interoperability of the battery. So we will have more and several different batteries that will fit in different swapping stations, that will fit in different brand motorcycles. In other words, what we will have is the picture on the right side of the screen. So the battery will be interoperable. They will go into different vehicles, but at the same time, they will be made by different brands, and what is inside the battery can also be different. So the chemicals of the cells and whatever can be different from one battery to another one. This is to guarantee, of course, the competitivity, the technological improvement in the futures, and of course also avoid antitrust problems. So this is the roadmap of our STANFO-SWAP project. On July of this year, we will have this intermediate workshop on focused on the concept of interoperability. On October, we will have our final workshop where we will share the final result of the project, and the project will end in November of this year. 2 QR code, one for the LinkedIn page, and the other one to subscribe to our newsletter and keep in touch. Thank you very much.
All right, thank you so much, Tommaso. So with that, we can move to the discussion part of the event. For the first question I would like to pose, it was, I believe, addressed towards Emrah and Alijan. And the question on that was, in the case of fixed swapping stations, like on your last slide, fully automated or not, how many stations do you estimate will be necessary at European level? What might the total cost be of this?
I can answer this quickly. We didn't study anything about this, and the ZEV-UP project is not about the commercialization of the swapping station either. But that is the next stage after we finalize the project and our first prototype.
Okay, thank you.
Thank you.
Yeah, Daniel, I would like also to shortly answer to that. Yeah, indeed, as Emrah mentioned, in this project, we are not looking into that specifically, but in our exploitation activities, you know, when more project progress and then more we will know more. And I believe at the end of the project, we will have also some maybe estimation, but you know that there could be also different scenarios and we have to deal with that, you know. So it's about L7E category, you know, how many vehicles, how many swapping per day, I think somehow we can also find some data, also compare this data with other regions, why not with China and so on. But yeah, hopefully we will look into that in our exploitation activities, and then I think then we need to wait a little bit more, like in a year or in maximum 2 years. This estimation will be somewhere there. But hopefully, Damien, yeah, you will stay with us, and then you will know as well. So you will follow up with us. You are part of the advisory group.
Okay, thank you. There was another question that we got on the Q&A. I believe, well, I'll let you answer, Eamon, and then if there's any other comments from any of the other speakers, they can also respond to it. But the question is that they would like to inquire on the estimated cost of the ZEV-UP solution and whether it is designed for deployment in international contexts, particularly within developing countries.
Yeah, I will try to take this question, and then I think Alican and Emrah also can answer and then provide even more clarification. So as we said when I presented the ZEV-UP project, we have 3 versions. Even I can share my screen very quickly so that it's you know, with the images maybe it's much clear. Okay, yeah. So as we said, we will have 3 different versions, variants, and then the first one is 2-seater, again with this storage for the travel bags and so on. So this vehicle will be around 8,500. Well, we of course our plan, we had these ideas in mind 2 years ago. And then you know that in 2 years ago, there has been also some change, especially for the inflation and so on. Now, for the second version, which is a longer version, longer wheelbase, and then it will accommodate 4 people with again storage space. This will be around 10,500. And the third one will be around 10,000, which is the commercial vehicle dedicated for the small businesses and so on. But we are also looking into the international aspect, and therefore in the consortium we have also 2 partners, and we studied also this aspect. So in our vehicle design development, we are taking this also into account. But I would say, Emrah and Alican can correct me, but mainly we are targeting Turkish market, European market. But again, it's not, let's say, purely commercial project. It's somehow, you know, research and innovation, so more innovation project. We are trying to design, develop, and demonstrate these vehicles in this project, and then, you know, hopefully after the project closes, there will be also other developments so that, you know, these cars will be in European and also international markets.
Okay, thank you. Are there any other speakers that would like to add any other points? So, answered comprehensively. We've just received another question in the Q&A. When checking user expectations in the ZEV-UP project, how about safety expectations of users? Do people expect some safety as normal M1 crash, crash impact protection, or can they live with lower safety that comes with category L6 and L7 vehicles, no crash protection requirements?
Maybe I can answer. First of all, today the L6 and L7 category is growing, and there are some European OEMs which also bring in such vehicles to the market in addition to the Chinese ones. And since these are growing, so from the expectation point of view, I guess there is no such expectation from the users. Because currently none of these vehicles have any kind of crash safety precautions that we see of, at least. But what we would like to bring in with ZEV-UP is an additional crash safety precautions. We cannot say it will be like the N1 level, then basically it becomes an N1 level. We cannot do that, as we cannot increase the weight of the vehicles. But we would like to bring some innovations. I cannot say them right now, but we would like to work on that in the project in the upcoming, I would say, 12 to 18 months, and hopefully bring in a better crash safety aspect for the ZEV-UP vehicles, which is above the current market's level.
Okay, thank you, Emrah.
Thank you.
Are there any other questions or any other comments that from any of the speakers or from any of the attendees? I had a question with regards to it's an open question for all of you to respond to. I think we hear oftentimes in the sector about range anxiety, and I think it's interesting when considering user needs that this is something to take into consideration. But I think it's interesting when we're talking about the use of ultra compact vehicles that the ranges tend not to be very, long distance journeys that are being taken. So is this a key concern, or are there other concerns for users that should be prioritized over this comment on range anxiety that was brought up in one of the presentations?
From ranging standpoint of view, I think that this is not an issue, for at least for the mini mobility vehicles, because the users are all in urban areas, and they usually know their travel. And currently, at least in ZEV-UP project, we are bringing in a range which they can easily live without charging their vehicles for several days. So this is not going to be an issue. Right now, when we look at the B segment electric vehicles that are an M1 vehicles, basically, they have around 300 to 400 kilometers range. So when we bring a 150 kilometer range for a mini mobility vehicle, I think this is much more than expected by the end users. Even the commercial end users, I would say. Alican, do you have any addition to this?
No, I agree with you.
Okay, thank you.
Danielle, maybe I can add a few lines there as well, what Emrah said. Yeah, indeed, this is the ZEV-UP car is purely for urban use, as we said, and then somehow we know that usually what we do, we do for daily trips, we are going to work place, so we do 5-10 kilometers, let's say. And the ZEV-UP car will have the range of around 100 kilometers and even more, I think. And it's really good for really full day operations. And then, for the full operations, I don't think that there would be any range issue. But then, these swapping stations as well, we have to also consider, because they will also bring the solutions, right? Because if your battery is depleted, you can go to the battery stations and then swap your battery in a couple of minutes, like what we do with the traditional cars. So in that sense as well, this range will be also done. But again, yeah, this ZEV-UP car is intended to be used for last mile delivery, for purely urban use. So I think, yeah, in terms of range anxiety, ZEV-UP car will meet the expectations.
Great, thank you. I think it is also a matter more of convenience, as mentioned, with not having to charge it constantly, and having a bit more flexibility with charging needs on that front. Another question has come through. So besides development, how do you integrate EU in the future production process? In other words, what are the chances, opportunities of making those vehicles made in Europe? What are the risks of future massive made in China imports? And I don't know who would want to respond to this. So can take a moment if anyone has any.
Yeah, maybe I can answer.
Sure, please.
Okay, first of all, it's a small volume manufacturing vehicles. So in that case, your body material and production technologies should be different than the traditional passenger vehicles based on sheet panels. In our ZEV-UP project, we use composite materials for the upper bodies, mostly from the natural fibers, and we combine this upper body with a metal underbody part. So in that case, you can produce these vehicles without huge tooling investment, which is must for sheet metal vehicles. And by that way, that will allow us to manufacture these vehicles in different regions of Europe separately. And for example, for the local production and for the local demand, you can build a small plant with the annual volumes around 10K. And by that way, you can provide a demand-based or region-based manufacturing. And sometimes maybe you can customize the vehicle and the processes regarding the local dynamics as well. This is what we are planning. Instead of a 1 point big production with a huge tooling investment, we are planning to produce these vehicles in some local places regarding their own dynamics and demands.
Okay, thank you. Is there any other comment from any of the speakers on that point?
Yeah, if then you allow me. Yeah, I think there are really opportunities for, as Damian said, made in Europe for ZEV-UP vehicles as well. We know that there is also the really good framework of industrial policy from the EU is there, somehow Green Deal and other industry acts that we can mention, and they are really pushing for having more battery electric vehicle, efficient battery electric vehicles or clean vehicles. I think this can be also kind of good driver. But also at national level. Well, I'm from Ertico. Ertico is based in Brussels, and we are dealing mostly with EU framework. But I believe that at a national level, there should be also programs. There are programs pushing for it. But overall, I think there should be good public-private partnership, really providing, I don't know, the infrastructure, the standardization aspect, as Tommaso mentioned. If these L7E categories can be coupled also with other vehicle categories in terms of swapping battery swapping systems, it would be great. I mean, we talked also about the battery swapping business models, like a battery as a service. If in the future there could be really, let's say that batteries will be owned not by the car makers, but by the battery asset owners, let's say. So basically, if you pay the battery electric vehicle, I don't know, 15K, and then if your battery, you do not own the battery, and the vehicle will come without battery, and then your cost will be really lowered. And then there is this model so that you can really swap your battery. So this cost reduction can also have impact, and maybe there also could be really good competitive advantage compared to I don't know, Chinese models and so on. But in order to have critical mass, maybe we need also Chinese vehicles in Europe, so that maybe the from the European side as well, this can be also really good push. So my personal opinion is that we shouldn't see the Chinese or Indian or other vehicles as a really let's say rivals that but I mean, this is really good for the competition. Again, it can be really good to leverage, but overall, yeah, I think that the good public partnership, really efficient partnership, can really push this made in Europe vehicles, and then we can have really a good market there. But yeah, hopefully with our exploitation colleagues, FEV and others, we will be able to look into that as well in this project.
Great, thank you, Eamon. Unless there's any other comments from any of the speakers, I will pose the final question, I think, for the webinar. There's a question: beyond the immediate benefits, how to address the life cycle sustainability of these vehicles, including battery production and recycling. I see Tommaso has raised a hand. So
Yes, just a quick comment on this. Standardization brings with it many benefits, and one of these is related to sustainability and recycling. For example, standardized battery will be much more easily recycled, but also reused for second life purpose. Because if you have all same batteries with same connector, etc., same dimension, it is much more easy to organize the supply chain behind this, and also the second life repurpose for that batteries that can be reused in different way after they have been used many times in vehicle and swapping systems.
that's clear. Is there any other points that any of the speakers would like to respond to on this?
Yeah, then I would like to add as well, among the innovations that we presented, yeah, I think this the questions come from Sheng. So thank you very much for the question. Yeah, among the innovations that we presented today, we had also this lightweight side, the modular architecture, and also the material selection. And then we are looking also into this eco-design standards as well. And the fact that the ZEV-UP car will include a swappable battery system, I think there as well we are somehow contributing to this process. So it means that for the batteries it will be swapped, it will be available there, and then we would use lower raw materials and so on. And you know, the batteries will be owned, let's say in the future, by battery swapping stations, battery asset owners, and then, you know, you don't need really high capacity batteries and so on. So this compact size batteries would also allow the batteries that you do not use, let's say, those materials and so on. So in that sense as well, I think, yeah, the ZEV-UP project is also contributing to this process, but also for for the second life of batteries as well. I think we have also an activity looking into that. I don't know if our colleagues from ZEV-UP consortium can answer that, but I'm not expert there. But maybe Haibo and other colleagues. But yeah, we will be looking into that as well. How as you said, address including battery recycling. So this second life or end of life strategy, yeah, we have to cover in this project.
All right, thank you. I will open the floor to see if there's any last comments or questions. And if not, we can close. I welcome everyone to turn their camera on again, just to say a final thanks to our speakers for their nice presentations and for the discussion. It's been a nice hour and a half. Thank you to all the attendees, excuse me, that could join us. Again, this will be available, the recording will be made available, and we welcome you to check out the ZEV-UP and the Stand for Swap websites. And with that, we can close this webinar. Thank you so much.
Thank you very much.